This is a video about how to analyze a video that lives on YouTube. So here's the video I want to analyze. A bear is falling out of a tree and landing in a trampoline. So is that mean or is it humane? That's the question I want to answer. So every YouTube video has an identifier. So this 9KIJNTG OPPI, that is an identifier for this YouTube video. So it's kind of like an address. If you have Python installed, you can write a Python program that will grab this video and save it to your hard drive. So this is the notebook that I'm using. Specifically, there's a Python module called pytube, and if you install that with pip and then import pytube, you can run this pytube.youtube function to identify an object, and then you can run this other function over here, and the last one is download. So this is just a string of commands, and what the string of commands does is grab the highest resolution MPEG-4 version of this YouTube video. I haven't tried this on every video in YouTube, but I've tried it a few times and it does seem to work. So you run that command, and then you have in your file manager a video. So I've saved this for the Physics 221 class. So here is the same video. It's the bear falling out of the tree. So it starts with the late night host, here's the bear, here's the trampoline,
equal comedy,
and the bear falls out of the tree. So this is a video that's saved on my hard drive. So this is a real feature because if it's saved on my hard drive, I can analyze it with a program called Logger Pro. So when you open up Logger Pro in 221, we've done this a few times, you can insert a movie. The movie that I'm going to insert is inside of my OneDrive. So here's day 4, this bear falling out of the tree. And then you remember when you're analyzing a video in Logger Pro, you need some kind of calibration. You need something to tell you about how big things are. Now, if you look at this police officer, I think this police officer, he looks like an average-sized male human in North America. So what do you think? Is his waist about 3 feet off the ground? That's the calibration that I'm going to use. So you go to where you actually have the motion you want to analyze. So they use a tranquilizer. So here we are. You want the camera to zoom out appropriately. So there's the bear. It's falling down. So a few frames forward. So I'm gonna say right there is where I'm going to analyze it. We back up a few. So you click this 3 red dots on the right hand side, and then this horizontal ruler sets the scale. So 3 feet is about 1 meter. So I am going to estimate that this is 1 meter tall. If I wanted to say instead that it was 38 inches, you can do that as well. But I'm going to say it's 1 meter. This is probably the main source of error in my video analysis. So once you've got that, you can track an object with this add point option. So I'm just going to click on the bottom of the bear as it falls. And then I'll click on the bottom of the bear as the bear rises. So again, the question is this a humane thing to do? That's what we want to answer. So the other thing you might notice is that as I follow this bear, the cameraman is a good cameraman, and the person is following the motion with their camera. So there's some camera shutter. Okay, so I think the bear is stopped now. So So if you look at the graph is mediocre, and I think we could do a better job to get rid of the camera jiggle. So I'm going to take this graph and make it smaller. Click right here, click on the graph, and I'm going to add another point series. So this point series is going to be the window, because the window of the house doesn't move. There's no earthquake. So I can find the difference in position between the window and the bear, and that should tell me how the bear moves. So I'm tracking point series 2. Now I'm going to click on this lower left-hand corner of the window, because I think that's in the frame the whole time. So there we go. And so this is not going to be as exciting as tracking the motion of the bear, because I'm just clicking on a window. But houses don't normally move, so it's a great thing to track. Now, is it legal to grab a video on YouTube and save it to your computer? I don't know. I'm not an attorney. This isn't legal advice. I've heard that if you use videos from YouTube in your teaching, educational purposes, that is considered fair use. I don't think that it would be ethical to grab a video off of YouTube and sell it, though, right? Because you'd be selling somebody else's intellectual property. Okay, so now we have the red dots, which are the track of the window. So you can see the camera moved quite a lot because that is the window. And then we have the blue dots, which is the track of the bear. So if I switch to the graph, here is the graph. I want to find the distance between the window and the bear. So the first thing I need to do is get rid of the horizontal motion. I'm not interested. And I also need to insert a column that is a little bit of math. So under Data, under Data, you can create a new calculated column. So this will be, we could just say it's Y difference. We could call it YD for the difference between those two Y measurements. The units will be meters. And then you just need to enter in a function. So, some kind of math. So my math is going to be the position of the bear minus the position of the window. There, shazam. So I've got this red dot, which is the motion of the window, the blue dots, which are the motion of the bear, and then I'm going to add in the difference. So I've changed it to the Y difference. Now, to me, this looks a lot better than the motion of the bear alone. It's negative, right? So you can think about why that is. But the real thing I care about is that this is when the camera was moving, this period right in here. This should be a parabola. And it isn't a parabola until you find the difference between the window and the bear. And then you have this beautiful chapter 3 parabola. So the question is, what is the speed of the bear when it hits the trampoline? That would be right here. And what is the speed of the bear when it hits the ground? If this was a humane thing to do to a bear, the speed would be less than it would have been. The trampoline would have reduced its speed. So how do you do that fit? So the simplest thing to do is just to grab a few data points with your mouse and click a straight line fit. So let's fit the difference. So it looks like the bear, when it was about to hit the ground, when it was about to hit the trampoline, the bear was moving at about 10 or 11 meters per second. So that's about 20 miles an hour. The bear, after it bounced off the trampoline, dissipated some energy. I don't really believe in these last 2 points. So the bear right here, when it was about to hit the ground after it had bounced off the trampoline, hit with a speed of about 4.5 meters per second. So that's about 10 miles an hour. So the bear went from 20 miles an hour when it hit the trampoline to 10 miles an hour when it hit the ground. So the trampoline was actually a humane thing to do to the bear. There, that's how you do video analysis. It's really useful.